Good morning, sir. Myself Mahesh. I am from Computer Science Department from CSDD section. I am here to speak about the topic free radical mechanism of polyvinyl chloride. You can see some of the diagrams where free radical mechanism. Uh, Content of the presentation is first introduction, types of polymerization, steps in polymerization, free radical mechanism, and free radical mechanism of polyvinyl chloride. We'll move to the next slide. And in the introduction part, what is polymerization? Polymerization is the process to create polymers. During polymerization, smaller molecules called monomers or building blocks are chemically combined to create a larger molecule, or we can also call it as macromolecule. Now you can in the picture you can see monomers there, and which are polymerized and formed a polymer. In the polymer you can see they are chemically combined, and this process we called it as polymerization. And what are the steps of polymerization? There are three types of polymerization. First one is initiation, second one is propagation, and third one is termination. In the first step, initiation is the first step in the polymerization. The initiation step in a radical chain reaction, in the step is where the free radical is first formed. In the first initiation step there is a formation of free radical, and in the second step, that is propagation. Propagation is the second step of the polymerization. The propagation phase describes the chain part of the reaction. Propagation is the main part of the reaction. It involves the main chain part of the reaction. And the third one is termination. Termination is the last step of the polymerization. It creates the formation of reactive intermediates in a chain propagation step in the course of polymerization, effectively bring it to alter. The termination is the process which gives us the final product after it gives the n number of polymers. And polymerization are subdivided into two parts. There are step growth, chain. Step growth again divided into two parts, polyaddition and polycondensation. In the second part, chain is subdivided into four types: radical polymerization, coordinative polymerization, cationic polymerization, and anionic polymerization. In this presentation, we are only talking about the radical polymerization. So we will move to the next slide. Now, my topic is free radical mechanism. So what is free radical mechanism? A free radical polymerization is a polymerizing approach by which the successive addition of free radicals takes place. While performing a reaction, there is a successive addition of free radicals. In the previous, we are observed in the picture that there is a successive addition of radicals so that they are chemically combined to form a polymer unit. Now, initiation of the polymerization. Initiation takes place. The polymerization of polyvinyl chloride begins with the generation of free radicals. In the first step only, through the definition, we observed that there is a formation of free radicals. And now, common initiation include peroxides, azo compounds that decomposes to form radicals. These radicals react with vinyl chloride monomers and starting the chain reaction. Now in the reaction is, what is the reaction? Initiation reaction. You can see vinyl chloride is reacting with the ether, which is of a radical, and it forms the OH single bond CH2 single bond CS single bond Cl. And mechanism of this initiation reaction is, you can see OH radical is transformed to CH2, and it gives the product as OH single bond CH2 CH single radical is single bond Cl. Now propagation is a very important part of the chain reaction. During propagation, a free radical reacts with the vinyl chloride monomer. This reaction creates a new radical at the end of the growing chain, and the process continues as the new radical reacts with addition monomers. Now the propagation step. You can see the product of a first initiation step. The product which was formed is OH single bond CH2 single bond CH, a radical up there, and with the single bond chloride, and it reacts with the vinyl chloride again, and it forms the OH single bond CH2 CH2 CS single bond Cl, and again CH2 with a radical CH single bond Cl. The mechanism of the propagation step is, you can see in the vinyl chloride with a single bond CSCl, it joins to the CH2 bond, that is OH single bond CH2 single bond CH, a radical there with Cl, and plus CH2 double bond CHCl. It forms the OH single bond CH2 single bond CHCl, single bond CH, and again a radical CHCl. The last step is termination of polymerization. Termination occurs when two free radicals react to form a stable product. This can happen only when the various mechanisms include coupling and disproportion. The termination step effectively ends the chain reaction, resulting the final polymer. In this termination, we get the final product, that is n number of polymers. Now we will see the termination reaction, and the product which was formed in the propagation step is there, that is OH single bond CH2 single bond CSCl, single bond CH2, and the radical CS single bond Cl, and it reacting with the n number of vinyl chloride, and it gives the product as OH single bond CH2 single bond CSCl, and again with the vinyl chloride, that is CH2 CHCl, and with the n number of polymers, it gives n number of times. The mechanism of this termination is OH single bond CH2 CSCl CH2Cl. You can see the mechanism when you observe the mechanism. CSCl, which free radical which joins this part of this section, that is CH2 CSCl, and it forms NCH2 double bond CSCl. Now the product is OH single bond CH2 CSCl and polyvinyl chloride, and it gives the n number of polymers. Finally, we will see application of the polyvinyl chloride. Where is polyvinyl actually used? Polyvinyl chloride is extensively used in construction, electric cable, insulation, and packaging. Its properties make it ideal for pipes, flooring, and medical devices as well. We use mostly polyvinyl chloride in the hospitals. The versatility of the polyvinyl stems from ability to modify its characteristics. Now, what are the environmental conditions? The production and disposal of PVC raise environmental concerns. So it is the biggest effect on the surroundings. Free radical reactions can lead to the generation of toxic byproducts. Sustainable practices are being developed to mitigate these impacts. Finally, conclusion. The free radical mechanism plays a critical role in polyvinyl chloride synthesis. Understanding this process helps in enhancing the material's application and sustainability. Ongoing research aims to define the polymerization process for better environmental outcomes. Finally, we are concluding this presentation by thank you and